Hi! Today we are going to talk about graphing linear inequalities in two variables. See, back in the day, when it was one variable, you'd have a number line, and then you just put a circle somewhere on that number line, and you either fill that or don't fill it in, and you go that way or that way, depending on which way it tells you to go. Now we have two variables, and it'll look a little something like that guy. So that is a two variable inequality. So I would graph that on a coordinate plane, as you can see right there. Now there's two things that you have to remember, two caveats. If you remember what graphing an inequality looks like, you are saying by filling that circle in and going that way, all of these guys are my possible answers. Same thing here. We are going to graph on a coordinate plane all the ordered pairs, so x and y values, that are possible answers to that equation. So if I give you a less than or equal to or a greater than or equal to, when I graph this line, I'm just going to graph it like a normal equation and make the line solid. Nothing's changed. Why am I making the line solid? Because if it's or equal to, I'm including the line. So when I don't have the equal sign, when it's just less than or greater than, I'm going to dash the line because the line doesn't count. Just like if I were to graph it, I would have a circle, but I wouldn't fill it in. Now that's caveat number one. Either you make it solid or dashed, depending on whether it has an equal sign attached or not. Caveat number two is I care about shading above the line or below the line, above the mountain or inside the mountain. And I shade above the line if it's greater than or equal to. I shade below the line if it's less than or equal to. So let's move my face. I don't need to have the word how there. Let's graph that guy. Again, I graph this normally, but I have to remember, do I make it dashed or solid? And do I shade above or below? That's what I'm looking for. So if I were to graph that guy normally, it's in slope-intercept form, but with the less than or equal to, I would start out by drawing the -5 right there, and my slope is positive 3 over 5. Positive 3 over 5. So up 1, 2, 3, right 1, 2, 3, 4, 5. And those are the only dots that I can make. I'm out of room. Now I need to draw my line. Do I make it solid or dashed? Solid because it's less than or equal to. So I'm going to draw my line as usual. Bada bing. Now I need to determine whether I shade above or below the line. I wish I had like a highlighter thing, but I'll just use big pen. Oh, I do have a highlighter. Yay! All right, now what I have to do is I have to decide if I shade above or below the line. This is a less than or equal to. Less than or equal to. So I'm going to shade below the line. Here's my line. Shading below it looks like that. I thought I'd choose. Yeah, it's not that. Let me choose green. Yeah, that's better. That's better. Okay. What this means, and I'm going to repeat myself affinity times. What this means is, here's my original inequality. So many choices to choose from. There's my original inequality, right? If I were to plug in 0, 0, that wouldn't make sense because it would say 0 is less than or equal to 0 minus 5, which is 0, just -5. So 0 is less than or equal to -5? No, it's not. All of these points here, so 5, -5, that dot right there, if I were to plug into the original equation, would be a true statement. So again, I'm choosing all of these dots are saying all of these points, whether it's whole numbers, decimals, whatever, these are all coordinates that if I were to plug into that inequality would give me a true statement, including the points on the line because the line is solid. So if I were to plug in 5, -2, that point right there, it would be a true statement because it would say -2 is less than or equal to blah, 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 -2. And -2 is less than or equal to -2. So it all works out. It all works out. All right, let me do another. I should be okay with my face. All this room, and I don't need any of it. I'm going to graph this normally, and I'm going to make sure my line is solid. Why am I going to make sure my line is solid? Because that's a less than or equal to, which means my line is solid. So there's my y-intercept at -4, put a dot. That is a positive slope, so up 4 over 3, up 1, 2, 3, 4 over 1, 2, 3, dot, up 1, 2, 3, 4 over 1, 2, 3, dot. And I'm going to make a solid line because I'm including the line because it's or equal to. Now I have to figure out where to shade. If it's greater than, I shade above. But in this case, it's a less than, so I'm going to shade below the line. So I'm going to shade this area here. You might be able to hear my almost 2-year-old in the background yelling, as she always does. What that shaded area means is all of these coordinates, 5, 0, 3, -3, 0, -6, all of those coordinates, if I were to plug into this original inequality, would be a true statement, including if I were to plug in 6, 4, because if I plug in 6, 4, I would get 4 is less than or equal to 4, which is true because 4 is less than or equal to 4. Okay. So that one was very similar to the first one because positive slope, negative y-intercept, less than or equal to. So very similar problem. Hopefully this next one's going to be different, and it will be very different. In fact, it's not even set for y. So there's a reason why I gave myself all that space, so I could solve that inequality for y. So let me do that now. I have 3x minus 2y is less than 10. If I want to get y all by itself, the first thing I have to do is subtract 3x from both sides. Subtract 3x from both sides. Sorry, a pop-up just popped up, so I'm getting rid of it. That goes there. -2y is less than. I want to make that look as much like slope-intercept form as possible. So -3x plus, because it's positive 10, bada bing. Is y all by itself? No. What's in the way? -2. How do I get rid of -2? Divide both sides by -2. And let us not forget that when you divide an inequality or multiply an inequality by a negative, you have to flip the sign. So y is now greater than -3 over -2 is going to be positive 3 over positive 2 because a negative over a negative is a positive. X, positive 10 divided by a -2 is -5. So I'm going to put a dot at -5, another negative y-intercept. Oh, look, another positive slope. Didn't do a really good job figuring these problems out. Up 1, 2, 3 over 1, 2. That's what I get from stealing them off the internet. 1, 2, 3 over 1, 2. 1, 2, 3 over 1, 2. All right, on to the graphing part. Now is when things get a little crazy. I have a I have a greater than symbol. Okay, that's dead to me. So we're not going to worry about that symbol because it's now greater than. I have a greater than symbol. I don't have the equals part attached to it, which means I'm going to make my line dashed because the line does not count. What's new here is the fact that it's greater than. So what I'm going to do is I'm going to shade above the line, which is all of this. I meant to choose the bigger highlighter, but you guys get the idea. All 4 of you who watch my videos. Which means if I were to look at the original inequality, so you're no longer dead, unshun. If I were to plug in 0, 0, if I were to plug in 3, 3, if I were to plug in -6, 0, if I were to plug in any of these purple coordinates, even the decimals, into the original equation, it would make it true. For example, if I were to plug in 0, 0, it would be 0 minus 0 is less than 10. 0 is less than 10. Boop. Now, if you're wondering, what about the dots on the line? No, because if I were to plug in, say, 4, 1, and plug in 4 for x and plug in 1 for y, I would get 12 minus 2 is 10. 10 is less than 10? No. 10 is 10. And we're not including the equals. So we're not allowed to include the dots on the line. Tricky, tricky, tricky. Tricky, 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 tricky. The easiest of them all. Back in the day, you learned that if I were to ask you to graph something like, I don't know, y equals 5, it would be a line straight across horizontal 5. You would pick 5 right there, so you would say 5 right there, y is equal to 5, boom, boom, boom. If I were to ask you to graph x is equal to -5, you would go where x is -5 and draw a vertical line. Is this much different? No. Because I'm going to go to x is less than -5. Do I make it solid or dashed? Dashed. I'm going to draw a vertical line that's dashed. And I care about everything smaller than -5, so to the left of -5. So I'm going to shade everything to the left of it. I don't have a lot of space, but you get the idea. So if I use the point -6, 1 and plug in -6 for x, and if you're like, what about y? Who cares? It's not there. If I were to plug in -6 for x, -6 is smaller than -5. So it's kind of like if I were to take, if I were to ask you a while ago to graph that on a regular number line, you would put a circle at -5 and have it go to the left. Well, it's kind of like if I took that line and stretched it out into a coordinate plane, nothing changes. But now I'm including y's, but I don't have any y's. So it would be wise for you to heed my words. Thank you so much. That's it. Bye.